Let's talk about the reduction of aldehydes and ketones. Reduction is the opposite of oxidation. So in a reduction reaction, the number of carbon-oxygen bonds would go down, would decrease, or the number of carbon-hydrogen bonds would increase. For an aldehyde or ketone, they are reducible, and they can be reduced by adding hydrogen gas along with a catalyst. The catalyst is usually a metal, nickel, or platinum are very common to see there. So here I have my aldehyde right here. There's my hydrogen right there. This is a reduction. I'm adding hydrogen to it. This can also be classified as an addition reaction because I'm going to add that hydrogen to my aldehyde. My hydrogen is going to add in two spots. I can think of the hydrogen like that. I really have two hydrogen atoms there. One hydrogen atom is going to add to the oxygen. The other hydrogen atom is going to add to the carbon that is bonded to that oxygen there. So my product would look like this. There's my oxygen. It's going to pick up the hydrogen like that. And there's my other hydrogen just like that. If you look at that, I have just formed an alcohol like that. And specifically, I have formed a primary alcohol. The carbon that is attached to the hydroxide group is only bonded to one other carbon in that alkyl group. The other two bonds are made to hydrogens. So anytime I reduce an aldehyde, I'm going to get a primary alcohol. This should look a little bit familiar when we talked about oxidation, because essentially we just did the opposite of an oxidation. When we talked about alcohols, we looked at the oxidation reaction, and if you took a primary alcohol and you oxidized it, you got an aldehyde. If you take an aldehyde and reduce it, you get a primary alcohol. They are opposites of one another there. Here's my ketone, two alkyl groups on that carbon right there. Here's my reaction conditions for a reduction. I've got hydrogen and I've got my catalyst right there. Same thing is going to happen. There's my hydrogen. One hydrogen atom is going to add to my oxygen. The other is going to add to my carbon right there. So I'm going to add this to my ketone. So there's my alkyl groups right there. There's my oxygen that just picked up a hydrogen, and there's my other hydrogen right there. So again, I've made an alcohol, and in this case, this is a secondary alcohol because the carbon that's attached to my hydroxide group is bonded to two other carbons right there. So when you have a ketone and you reduce it, you always get a secondary alcohol. So aldehydes give you primary alcohols, ketones give you secondary alcohols. Again, this is exactly opposite when we looked at the oxidation of alcohols. When you oxidized a secondary alcohol, you always got a ketone. If you start with a ketone and reduce it, you're going to get a secondary alcohol.